Hello students, let us continue the same chapter, some basic concepts of chemistry with different topics. So previously I explained the representation of an atom, what is the meaning of mass number and atomic number. This is required for the next topic. See, the next one is mass number versus atomic mass. It sounds same, mass number and atomic mass. What makes a difference? There are differences between mass number and atomic number. First, let me explain mass number. Mass number is the weight of the nucleus of an atom. Mass number is the weight of nucleus of an atom. Mass number is written on upper left hand corner of elemental expression. Already I have written. Mass number does not take the existence of isotopes. This point is very important. Isotopes. Let me explain one by one. The mass number is a simplified number usually without any decimal places. Mass number is easier to use for a general purpose. For example, you take magnesium here. So magnesium is written. Look here, magnesium. What is the atomic number? 12. So what is the symbol for magnesium? Mg. 12. Corresponding to magnesium here, it is 24.30. I am writing 24. So this is mass number, this is atomic number, right? So mass number is sum of protons and neutrons. Atomic number is number of protons. Okay, protons and neutron, it gives mass number. Only the proton number is atomic number. If I ask you what is the mass number, you will tell 24. Just look into the difference. I have written 24, but here mentioned atomic mass in AMU, it is 24.3. Why it is 24.3? Decimal place can be seen, but I have not written any decimal here. It is only whole number 24. The reason is some of the elements in the nature, it exists in the isotopic form. They are said to be isotopes. What is the meaning of isotopes? Isotopes can be explained with the help of these elements. Let me take one small example and which is much familiar to us. Look here, carbon. What is the symbol of carbon? C. What is its number, atomic number? Carbon atomic number is 6. What is its mass number? Mass number, look here, total number of protons and neutrons, 6 plus 6, it is equal to 12. Carbon 12. They have mentioned carbon 12. What is the purpose of mentioning carbon 12? It can be written carbon. The reason is carbon exists in 3 forms: carbon 12, carbon 13 and carbon 14. Here, if you observe carefully, the number of proton 6 in the 12, number of proton in 13 is 6, number of protons in carbon 14 is 6. So, in all the cases, carbon 12, carbon 13, carbon 14, proton number is fixed, that is 6. So 6 protons, it is atomic number is same, no changes. But what is happening? What is happening here? Observe the neutron. In the first case, it is 6, 6 plus 6. 6 proton, 6 neutron. This is carbon 12. Take another, they have given 13. 13 means, being it's a carbon, number of proton remains same, no changes. Proton is same, but what is happening? Neutron number is adding up. So 6 plus 7. Look into the carbon 14. See 14. Proton number is same 6, but number of neutron is 8. 6 plus 8. See, in all the cases, the neutron number is increasing. As a result of increase in the neutron number, what happens to the number of protons and neutron? It also increases. Here you get 12. Here it is 13. Here it is 14. So what happens when the number of protons and neutron increases? Its mass number increases. So each the species related as isotopes. Isotopes mean all are carbon, no doubt. Why it is a carbon? The number of proton remains same, hence they are the atoms of same element, but they differ with respect to number of proton. As a proton number changes, mass changes. So a species which differs with the mass number, but they have same number of proton or same atomic number, they are said to be isotopes. What is the importance of isotopes? Isotopes are very much required to decide the atomic mass. This is why you got different values. You got decimals here, 6.94, 1.08, 22.98, 24.30. What is the purpose? What is the main reason for getting 24.30? You take a carbon, it is not 12. Carbon is given 12.01 because these isotopes does not exist in the equal distribution pattern. Rather, the distribution in the different pattern means one of the isotope may be 50%, second may be 30%, another is 20%. In certain cases, it may be 0.2%, it may be 1%, less than 1%. Like this, the distribution is not equal. We are supposed to consider its abundance. Abundance means how much it is available. So how much it is available in the nature, it is represented as abundance percentage. Abundance percentage is to be considered to determine atomic mass of an element. This is said to be relative or average atomic mass. Average atomic mass, we are considering its isotopic form. So how to calculate that relative or average atomic mass? It will be explained. So before this, we should know the difference between mass number and atomic mass. So mass number is the weight of nucleus of an atom. Atomic mass is average weight of an element form. Average word we are using. Whenever the average is there, we should consider its isotopic form. So we are not considering its isotopic form, we are taking an atom and how much protons are there, how much neutrons are there, we are adding up and we are giving a number. It's a simple number, that's called a mass number. So atomic mass, we are considering its isotopic form along with its abundance distribution or percentage of distribution. Okay, atomic mass is not symbolized as such. No symbol. Mass number is written upside upper left hand corner of an element. Atomic mass relates to average weight of an element form, and therefore it takes into consideration along with their isotopes and its abundance. Isotopes and abundance. This is the difference between mass number and atomic mass. Majority of us will get confused over mass number and atomic mass. Whenever the mass number come, it's a simple number, sum of protons and neutrons. When it comes to atomic mass, we should consider its isotopes and percentage of abundance to calculate its value. With a simple example, let us discuss to calculate atomic mass. Atomic mass. Look here. I have taken chlorine. The two isotopes of a chlorine 35 and 37. So what is the difference here? In a chlorine 35, proton number is 17, no doubt. Chlorine 37 also, proton number is 17. As I said, as per the definition, isotopes are the species. These are the atoms of a same element. They differ only with the mass number. So mass number is changing. This is 35, this is 37. What is the reason for change in the mass number? Number of neutrons changes. In the case 35, the number of neutrons are 18. Here the two neutrons are added up, it is equal to 20. Okay, fine. Now mass number is different between the two. Second concept or second point here is percentage of abundance or distribution. In the nature, you find Cl35 75%. Another 25% is Cl37. It is not 50-50%. Therefore, to calculate atomic mass, its percentage abundance should be taken. So, what is the formula? Formula is relative. It is considered to be relative atomic mass. It is an average value of the isotope of element. It takes into account the percentage abundance of the isotopes. That factor to be considered. That is a percentage abundance. Okay. For example, I take chlorine 35. What is the percentage abundance? 75%. Into what is its mass number? 35 plus one more isotope is there, chlorine 37. So what is abundance? 25% into 37. So divided by total abundance, it is equal to 100. So we get 35.5. 35.5 is atomic mass. So if I ask mass number, you will tell either 35 or 37. When it comes to atomic mass, it is 35.5, not 36 or not 37. It is 35.5. Suppose if you add 35 and 37 divided by 2, it is not 35.5, it's a different number. So while considering its calculation, especially atomic mass, abundance factor should be considered. That is called percentage abundance. So this is the meaning of atomic mass and mass number. I hope it is clear. Let us take another example. This is well explained. So relative isotopic mass. Isotopic mass, it is 35. It is rounded up 35. Percentage of abundance is 20. 75 is taken. Here it is 25 for calculation. So divided by 100. There is a total abundance. 75 plus 25 is 100. So which is equal to 35.45. It is rounded up to 35.5. Okay, this is how relative atomic mass can be calculated. So this is very important. Usually we can expect question on this. See, you got one number here, 35.5, and they have mentioned AMU. What is the meaning of AMU? AMU, if I write 35.5, you asked, sir, what is that number? 35.5 means it may be liter, it may be meter, it may be kg, it may be gram, or anything. It has no meaning. So see, if I write G, so it clearly mention it is related to mass. So 35.5 means gram. You are expressing the mass of an atom in terms of a gram is said to be gram atomic mass, GAM, gram atomic mass, gram atomic mass. So if a mass of an atom is expressed in terms of gram is called gram atomic mass. Apart from this, we have another unit to express or explain the mass, that is atomic mass unit. It is nothing but AMU. What is the meaning of atomic mass unit? It's a different topic and very important. Listen carefully. Atomic mass unit. How this atomic mass unit was derived? See, atomic mass unit is a relative mass. Relative mass. You are comparing the mass of atom of one element with respect to a standard. With respect to a standard. Suppose you are visiting, you are going to buy a fruit. Okay, fruit shop. So you ask 1 kg of apple, 1 kg of apple or any fruits of your wish. What they do? In the conventional method of weighing, they will keep weight on one panel. With respect to that, fruits are added. Once the needle or right hand panel and left hand panel are aligned, it means the weight is equal to right hand side and left hand side. So with respect to the weight of this, other will be given. We don't know whether it is 1 kg or what. We are following that standard from many years. Same we are following. With respect to that, the weight is given to us. Okay. In the same way, the mass of an atom is calculated with the help of a standard, that is nothing but carbon 12 isotope. Carbon 12 isotope. You are comparing the mass of another atom with respect to mass of carbon 12. Suppose you know the length of this pen. It is around 12 centimeter. 12 centimeter. If I take this book, if I ask you what is the length, what you do? Simply, you don't have any other thing to measure. So, you will measure that book with the help of this. Very easily. So, you will tell it is 3 times, 3 times, 4 times length with respect to this pen. So, I know the length of this, it is the 15 or 12. 2 times means 24 centimeter. 3 times means 12 into 3, 36 centimeter. You are comparing an unknown with a known, hence it is said to be relative. It is exactly we don't know. One is taken as a standard. Here also we are considering carbon 12 isotope as a standard to determine or express the mass of other atoms. Hence it is said to be relative mass. It is a relative, not exact. So it's a comparison mass. So you may ask question, so why sir, what is the purpose of selecting carbon 12? Carbon 12 isotope is a stable, abundantly present in the nature. Because of its high stability, and inertness and uniformly, and it is distributed in the nature. As a result, carbon 12 isotope is selected as a standard. So they did experiment with the different atoms like oxygen was taken, and they failed due to many technical issues. Maintaining atmosphere 1 atmosphere pressure, purest form of oxygen should be used. It undergoes a reaction very easily with other elements. So appropriate and correct answers or results cannot be obtained using such a reactive species. Hence, they selected carbon 12 isotope. Now, I think you are cleared about two topics. One is mass number and atomic mass. Mass number is the sum of protons and neutrons. Atomic mass is a relative mass. It is calculated by considering the isotopes and its abundance, percentage of abundance. Also, mass number and atomic number, they are different. It is not same. It is not same. That is clear. Second topic is isotopes. What are isotopes? Isotopes are the atoms of a same element, but they differ only with the mass number. The difference in the mass number is due to change in the neutron number. As the number of neutron increases, mass increases, and mass number also increases. So, by considering its isotope, relative atomic mass should be calculated. We are discussing how to represent this atomic mass. Atomic mass can be represented either in terms of a gram. If you are representing through a gram, that is called gram atomic mass. Other method is AMU system. To explain AMU system, these are all the things required. What is the value of AMU? What is the meaning of 1 AMU? 1 AMU means what exactly it is. So as you know, here we are taken carbon. Number of proton is equal to 6, mass number is 12. Carbon 12 isotope is taken, not 13 and 14, 12. It means 6 protons and 6 neutron. Okay, it is clear. Carbon 12 isotope. Then we have one more thing here, mole concept. So mole concept, it will be explained later, but we will come across a mole. You should know what is the meaning of mole. Okay. Already we studied in fundamental units, amount of substance is expressed in terms of a mole. Mole is nothing but amount of a substance. It is MOL. Symbol for amount of substance is small letter n. What is the meaning of a mole? We are all familiar to dozen. Dozen means if I ask 1 dozen of pomegranate, you will count 12 numbers and give. 1 dozen of banana, 12 numbers you will give. 1 dozen of sapota, 12 numbers you will give. Irrespective of fruits, when I say a dozen, the count is fixed. It is equal to 12. Right? In the same way, when it comes to a concept mole, it is fixed irrespective of substance. It may be atom, it may be particles, molecules, any substance. When it comes to mole, 6.022 into 10 to the power 23. 23 atoms, 23 particles, 23 molecules. If I ask 1 mole of carbon mean, it is clear, it is equal to 6.022 into 10 to the power 23 atoms of carbon. 2 moles means 2 into 6.022 into 10 to the power 23 atoms of carbon. Half mole is equal to half into 6.022 into 10 to the power 23 carbon atoms. So this is the meaning of a mole. Mole is nothing but the amount of substance is expressed, it is equal to 6.022 into 10 to the power 23 atoms, particles or any substance. So another point arises. If I tell 1 mole of a carbon means, you know, number of particles 6.022 into 10 to the power 23. If I ask you to bring 1 mole of carbon, how much should be taken is the question, right? If I ask 1 mole of HCl, you know 1 mole of HCl is equal to 6.022 into 10 to the power 23 molecules of HCl. That number is known. To get that number, how much quantity should be taken is the question. It is very simple, very simple. If you want to get a mole of a substance, it should be equal to 1 gram atomic mass or 1 gram molecular mass. For example, oxygen. Look here, oxygen. Oxygen, whether it is an atom or a molecule, it is a molecule because OO is there. It is a molecule. Then what should be considered? We should consider molecular mass. How to calculate molecular mass? Molecular mass is sum of the atomic masses. Sum of the atomic masses. See, oxygen is 16. Another oxygen 16, which is equal to 32 gram molecular mass, 32 gram. If you take 32 grams, which is equal to 1 gram molecular mass. Suppose if it is a helium, its mass number is 4, atomic number is 2. Then what is the representation? It is GMM or GAM is the question. Look into the nature. Helium, it exists in the form of atom. So we should take gram atomic mass, not gram molecular mass. So what is atomic mass? 4. We are representing in the form of a gram. That is a gram atomic mass 4 grams. So this is the meaning of gram atomic mass and gram molecular mass. If it is a molecule, we are expressing in terms of gram molecular mass. If it is an atom, we are expressing in terms of gram atomic mass. Another example you take. HCl. It's a very important topics. Very important. HCl. Look here. How many elements are there? 2. One is hydrogen, another is chlorine. So, if I ask what is the molecular mass of HCl? Molecular mass of HCl, how we will calculate? You should know the atomic mass. This is why I said to learn at least 30 elements, its atomic number and mass number, because if you know that, you can calculate very easily. Hydrogen, its atomic mass is 1. Chlorine, atomic mass is 35.5. So it is 36.5. So 36.5 gram molecular mass of HCl. Gram molecular mass of HCl. Like this, we can calculate gram molecular mass and gram atomic mass. Why it is required in AMU system? Look here. So you know 1 mole is equal to 6.022 into 10 to the power 23 molecules or atom. This number is nothing but Avogadro's number. It is represented as Na. Avogadro's number Na, which is equal to 6.022 into 10 to the power 23, which is equal to 1 mole. 1 mole. I want 1 mole of carbon. Then to get 1 mole of a carbon, how much should be taken? To get 1 mole of substance, which is equal to its gram atomic mass or gram molecular mass. If you take this much, which is equal to 1 mole. Example, I want 1 mole of hydrogen, H2. How much should be taken? Very simple. Hydrogen is a molecule. Its molecular mass is 2 grams. If you take 2 grams, which is equal to 1 mole, which is equal to 1 mole. Oxygen, look here, have written O. O is atom. So what is atomic mass of oxygen? It is 16. Gram atomic mass is 16 grams. If you take 16 grams, which is equal to 1 mole, which is equal to 1 mole. In the same way, take carbon. I want 1 mole of a carbon. Carbon is an atom. What is its atomic number? 6. Mass number is 12. Then how much should be taken? Gram atomic mass should be taken. So what is the atomic number? 12. If you take 12 grams, it is a gram atomic mass of a carbon, which is equal to 1 mole. 1 mole contains how many particles? 6.022 into 10 to the power 23 atoms of carbon. 23 atoms of carbon. This is the meaning of a mole. Now, I think you are cleared with concept mole. Mole is nothing but it is a unit to express the amount of substance. Symbol is N, its unit is MOL. What is the meaning of 1 mole? 1 mole means it is the amount of substance. It may be an atom, molecule or anything which is equal to 6.022 into 10 to the power 23. To get a mole of a substance, what to do? 1 mole of a substance is equal to its gram atomic mass or gram molecular mass. So here the gram atomic mass of a carbon is 12. If you take a 12 grams, which is equal to 1 mole, 1 mole consists of Avogadro number 6.022 into 10 to the power 23. So this part is clear. What is the meaning? Okay, atomic mass is 12. So then what is the mass of 1 atom of a carbon? 1 atom of a carbon. Is it possible to pick 1 atom? No, it is very difficult, but we can calculate very easily. Suppose if you take 12 grams, which consists of how many particles? 6.022 into 10 to the power 23 atoms. If you divide this value with 6.022 into 10 to the power 23, it gives mass of 1 atom of carbon. Mass of 1 atom of carbon. Okay. So this part is over. Okay, fine. Then how to get the value of 1 AMU? 1 AMU means 1 atomic mass unit. Be careful here. So 1 AMU, a definition is there. 1 AMU is 1 by 12th mass of carbon 12 isotope into mass of 1 atom of carbon 12. This is the formula to calculate 1 AMU. You have two parts. One is 1 by 12th, another is mass of one atom of carbon 12. We have derived here. Mass of one atom of carbon 12 is known. Then what is the meaning of 1 by 12th? Why 1 by 12th is selected? Would have taken 1 by 6, 1 by 3, 1 by 7, 1 by 13 also can be taken. Purpose of selecting 12 is, see, mass is concentrated in the nucleus, right? Nucleus is made up of two things. One is protons, another is neutrons. So, in a carbon 12 isotopes, we have 6 protons and 6 neutrons. Combining 6 protons and 6 neutrons is said to be a nucleus. So, total you have 12 parts. The entire mass is concentrated in 12 parts. You are taking one of this 12. So you are taking one. The mass of proton and mass of neutron is almost same. That's where we are considering total number means mass number means number of protons and neutron is almost same. It differs only with the third decimal. Okay, 1 by 12. This is the meaning. So this part, you are calculating the mass of this part. The total parts are 12. Out of 12, you are calculating one part, hence it is said to be 1 AMU. Then you are comparing with others. Comparing with others. See, 1 by 12. Mass of one atom of carbon 12, it is derived here. 12 by 6.022 into 10 to the power 23, which is equal to, this is cancelled, and is equal to 1.66 into 10 to the power minus 24 grams, or 1.66 into 10 to the power minus 27 kg. So then what is the mass of this unit, which is equal to 1.66 into 10 to the power 24 gram. This is the value of 1 AMU. 1 AMU. Now you take hydrogen. How many proton is there? Only one proton. Then it is possible to represent in AMU. Yes, you can represent either of the ways. See, hydrogen mass number is 1. If I tell gram, it is a gram atomic mass, 1 gram. What is 1 AMU? We know the value, 1 into, say 0, say 1.66 into 10 to the power minus 24 grams. If you multiply that value, it is obtained in AMU system. 2 AMU means what? 2 into this value. 5 AMU, 5 into this value. Oxygen, number of proton 6, number of neutron 6, total 12. If you are representing in a grams, it is a gram atomic mass, that is a 12 gram. It can also be expressed in terms of AMU system by multiplying with this value. So this is also another method to express atomic mass. It is also called unified mass. Atomic mass is also called unified mass. It is represented as AMU. So this is about gram atomic mass, mass number and AMU system. So later we are discussing the mole concept. So mole concept, by taking some numericals, it is very easy to understand. Before that, get prepared with atomic number, mass number, symbols to calculate molecular weight and also atomic masses. Later it will be discussed. Thank you for listening.